Welcome, everyone, to the Polarian series of webinars. Today's presentation, Big Data Testing. Thank you for joining us, and we will commence shortly. Our presenter today is Reg Stroop, Product Manager with Polarian. He's been with Polarian for over 20 years. Reg has a huge background in commercial software development and testing. Reg has held multiple positions ranging from the head of technical product management for AGFA Healthcare to most recently the product evangelist for Polarian Q&A. He has developed several software testing tools such as Test Integrity, iTest, and Polarian QA. Reg is dedicated to the domain of test management and is continually analyzing and testing trends and how they impact the discipline of software testing. Welcome, Reg.
Thank you, Nancy. Hopefully everybody can hear me. Good morning, good afternoon, and good evening to our folks in Europe and in Asia Pacific. It's a pleasure today to be able to present this exciting topic on big data testing. Before we get into our topic, I'll tell you a little bit about our history. We're a privately held software company that was founded in 2004. We're a leading innovator in web-based requirements management, focused on ALM solutions, and our first product release was Happily in 2005. We have a global presence. We have offices in North America. Our corporate office is in Stuttgart, Germany, offices in Czech Republic, Asia Pacific, and throughout the continental U.S. With business alliances in Australia, Brazil, China, France, and many other places. Focus, as I mentioned, is on application lifecycle management. What we've done is we've created a very innovative, collaborative web-based application that is focused on application lifecycle management. However, also focuses on requirements management and the test management of your processes and all testing activities. Start with talking about big data. This is a big industry term, and it's a lot of misconceptions, a lot of terminology, a lot of challenges, and a lot of solutions that have been bandied about within the industry. Talk about what works, what doesn't work, some of the pitfalls that we want to avoid, how we categorize big data, who's winning, and how to hopefully effectively be able to manage the testing of big data. Description of the perception of big data. So in this particular graph here, we show that, and the source was Polarian, is that what is big data? Do you agree or yes or no? So clearly, there's a mix between perception of companies thinking it's marketing hype, as well as, more importantly, is that a lot of organizations are starting to realize that there's some really good material to be able to analyze and use to technology advantage. What is big data? Well, data sets, basically large data sets, that the size is so large that the tools we commonly use today cannot process the results in an acceptable time frame. A complete transformation in how society processes large amounts of information. The rise of big data is as transformative today as the internet was a decade ago. Well, the reality is that a lot more data is being stored digitally. And the terminology we currently use is called datafication. What that basically means is that we've digitized data, and when we digitize it, we're actually quantifying data into a readable analytical format. So an example of that is GPS. We actually have geolocations that we've digitized, able to store geographical location information. Perspective into this. In 3000 BC, the largest amount of information, human information stored, was the Library of Alexandria. Today, think about it in these terms. Every person would have 320 times that amount in their own personal library. It's an explosion of data. Although it's relatively new, it's now doubling in size every 3 years. IBM says that we create about 2.5 quintillion bytes of data. So much of that data, that 90% of the data that's created has been created in the last 2 years alone. As well as Gartner believes that big data is big business. IT will spend approximately $34 billion in 2013 and rising to a whopping $232 billion by 2016. True or false? Data will save us. All we have to do is measure it. Once we've quantified everything, all of our problems, technical and social, will melt away. Obviously, false. However, there is a caveat. There will be new ways for us to be able to capture information, And there's emerging trends in how we comprehend this information, completely different to how we used to comprehend using smaller data sets. Telecom, high-tech, banking spend the most on big data. Utility and energy market and resources, they expect the highest return on the analysis of big data. Media and entertainment companies, they use the most unstructured data. High-tech companies use the most external of big data. And I'll talk about those in more detail, unstructured data versus structured data. Utilities and telecom companies are the most likely to sell their digital data to consumers, and insurance companies actually make the most of big data, the results from the analysis of big data. So where is this all coming from? Well, really what it is, it's called the Internet of Things. That is where almost all of the data that's digitized is being generated. From mobile devices to sensors, such as smartphones and barcodes that transmit RFID. Everything gets populated to the Internet. So what are the driving factors? I talked about the Internet, but what are those driving factors that contribute to the Internet? Well, clearly the highest is our smartphones, tablets, any mobile device. Overwhelmingly 60% is created by media, of mobile devices. Next follows is cloud computing. As we'll see as we move forward, is social media and video will continue to climb as well. Bottom line is most of this data is created through web content. Data construct. So it's a theory that's been discussed and expanded upon primarily by the Gartner Group and some various other technology analysts. So why a construct? Data has been growing dramatically, and we're asked to process this data in our daily activities and respond more quickly to how we actually interpret this data. We're now trying to characterize the traits of big data. In this particular example is the volume of big data, the velocity of big data, the variety of big data. In simpler terms, who created it, what was created, and when was it created? Again, why do we do this? To gain insights into big data, we break it down into the three characteristics. Volume, how much data is created. Velocity, how fast data is processed. And the variety of the various types of data that is actually inputted into the equation. Great variety of data types. They're rapidly changing or moving at high velocity. Some combination of three traits. Again, the volume, velocity, and variety. That in a nutshell is the three V's. So let's explore in detail the three V's. Let's start with data volume. That's primarily by transactional volume. For example, mobile and the internet, any transaction. Traditional data types. Well, there's new types arising as well. Some very unstructured types. Challenges that we have with the volume of data that we have to test and analyze. First one obviously is I have too much data to analyze. Compounded by the fact that the world, as I mentioned before, is getting more digitized and more connected every day. So the result is more data is being actually created. The volume continues to increase. We all experience data now is being created not only by employees, but customers and third parties. So extracting information from these large data sets becomes an issue. Not only because of the volume, but because they're complex and semi-structured. Now we have regulatory demands that increase pressure on us from a quality perspective while handling large volumes of data. And consolidation of data from systems and apps and the internet. All these sources have to be aggregated. There's missing data, data integrity. With large volumes that are coming at you at lightning speed, how do you manage the integrity of that data? What if there's pieces that are missing? I think this succinctly tells us everything about velocity. Every business now is a digital business, whether it's in your garage, your basement, or a manufacturer of mechatronics. Everything is digitized. Content is continually populated to the internet. Speed at which now data is being created is what velocity is, and it's lightning quick. We also need to actually analyze that data that's coming at us in real time to make sense of it, to make it useful, to stay competitive. Acquisition of data versus actionable insight. There has to be a balance in the time required for acquiring the data and the time required for interpreting meaningful results. So how quickly I can actually interpret it, but how useful that interpretation will be. data velocity. Again, the ability to implement a data-driven testing process. Want to improve response rates for decision making. Smartphone or web page, downloading info. Remember when we had smartphones? What the expectation is when we started using smartphones? The rate that we download media to our smartphones? Bottom line is fast isn't fast enough, and it will continue to accelerate. The third pillar of the 3 V's is data variety. You see here is various sources, but now more importantly is what is the type of structure of those sources. So we have structured information, which could be in column formats or traditional database formats, unstructured, semi-structured. Mobile devices, we've got search engines, media, structured and unstructured data. Unstructured data, which is something that's new to the equation, what it means is it doesn't reside in our traditional row column database format. Usually text heavy, can include books, articles, free-flowing text, images, media files, PDFs, web content, a variety thereof. It's estimated that 80 to 90% of data in any organization today is unstructured, meaning that it's a combination of all or thereof. Some very large challenges with this. It's compounded by the fact that 80% of data growth in images and video, which means more unstructured data. The number of data types, unstructured and semi-structured. So we have a combination. And the volatility of changing data. So what's being fed into our process can change in rapid succession, meaning that we can go from structured to unstructured to semi-structured. And the sources of the data. Continual sources such as mobile devices, obviously the internet, email, will continually populate that volatility. Move on to testing big data. From the characteristics that we talked about for the 3 V's, traditional methods of testing big data are not enough. When we test smaller data sets, the existing methods and tools were adequate. Now with the larger data sets and the volume and the type of data sets, those tools are clearly inadequate. Example, Microsoft Excel cannot manage effectively large data sets. Think of it in thousands of test cases with structured and unstructured data within those test cases. Also, the lack of knowledge. What do we test? How much data to test? The possibility of unknown scenarios is just expanded, and big data testing is gigantic when compared to testing techniques for conventional applications. Test strategies for structured versus unstructured data. The MXL dilemma. If you're probably aware of it, still the most used software for testing worldwide. However, there are some shortcomings. Data validation is an issue. How do you validate your data in an Excel spreadsheet? There isn't an actual history, an audit trail of what you're testing in an Excel spreadsheet. How do you store elemental data? Storing multiple data values such as sensor readings, temperature variations, how do you manage that from Excel? How can you create intelligent queries on multiple data sets and criteria, let alone collaboration, using an Excel spreadsheet across multiple locations, multiple environments? Reporting in a regulatory environment. How do you actually create meaningful reports on an Excel spreadsheet? Managing the process. Some suggestions here. Test early, test fast. Reduce risk and number of defects will reduce the costs when managing big data in testing environment. Identify whether a data-driven testing environment is right for you, meaning that creation of test scripts that run simultaneously with related data sets in a reusable framework. There's a compelling need to develop a very strong testing environment, a robust approach, for example, back to the test early, test often. Quality data with strong data sets. Investigate multiple testing methodologies. For example, functional versus non-functional. Automated frameworks. Data validation versus quality. Right data is extracted and tested. Validate your data requirements. Volume. Use large samples for your data sets. Expand beyond what we're using now as your traditional small data sets. Also explore the fact that you might have to use scripts, implement test automation. A process in place with an infrastructure that's designed to achieve new levels of scalability, reusability, and compatibility. You want to ensure comprehensive and continuous context-driven testing capabilities. Example, automate regression test suites where it makes sense. Data sampling. So we talked about having larger sample sizes. Well, what you're going to have to do is specify the sample size. Next is identify suitable sampling techniques. Include correct use cases. So what are the right data sets and the right use cases for you? So an example methodology. Validate your requirements. Prepare big data testing samples based on your requirements. Set up a configuration testing environment, so a framework that's robust and sound. You might want to implement incremental load testing. Now that you have large volumes of data sets, performance and load testing might be a more important requirement. Implement functional testing. So as you can see, we're implementing various types of testing methodologies. 5 ideas about big data. Start with the applications. We can have big ideas when we want to implement a tool framework, but it isn't worth much if we don't have proper ROI. So meaning, what do we want to get out of these tools? Think about innovation. When handling big data, a company structure that can think in new ways and encourage innovation before you get mired in the technology, the evaluation of that technology, is key to successful implementation of applications for your testing environment. Must have and foster an environment that will gather the tools to make your goals happen. So what this could mean is it's a shift in tools. And quite frankly, that shift might have to bridge a gap between your current processes and emerging trends. Out with the old and in with the new. We talked about here again, Excel is the tool that's used most commonly. As we mentioned before, is there some shortfalls or some shortcomings in handling large data sets. So we want to explore other avenues and other tools. Look at test management tools. And if you're not familiar with that, it's an application that will manage the entire life cycle of the testing process. It's recommended that you're going to want to implement a strong test management platform. Why? Because you can manage large data sets. You have the ability to manage multiple sources and types of data. So that's structured, unstructured, semi-structured. Manage the various large data testing activities. So whether it's performance testing, test automation, load testing, mobile testing, make sure that you can have a tool that manages all those testing activities. Integrations, requirements, your source control. You want to make sure you have tools that can integrate with your existing tools. And reporting and analytics. Should be looking for a tool that not only meets the requirements of your reporting for regulatory environments, but also analytics that can extract meaningful information for you to make decisions on your testing results, and being able to reuse those testing frameworks. Example is our Plarium QA software. It's a collaborative test management solution. Provides you a web-agnostic platform. Any device, anytime, can access it. Managing all your testing activities from one central platform. Integrate with what you have. Focus on testing rather than on the tool. We've got you covered. Make sure you have a tool that actually audits everything, like Plarium QA. And in any application, manage your testing process, not the tool. Number 2, develop a strategy. Now is the time for business to map out their high-velocity big data strategies. Characteristics of big data isn't going to go away. It's only going to increase. Right now, the current focus is on volume. But velocity may be the larger hurdle to overcome. Again, the issue is the ability to handle and be able to analyze quickly with meaningful results. So just think of it, you have all these various sources of data that's being put into your environment, and the formats are a mix, and you have to be able to manage that, interpret it, and produce results in a meaningful way. And in not real time, but in a timely fashion. Go simple, but go big. What do we mean by that? Well, basically simplicity. Simple tactics will most of the time trump complex methodologies. And the reason for that is you can provide insights much more quickly with surprising accuracy than trying to create sophisticated, very narrow test methodologies and samples. Example. Everybody obviously knows about voting in elections. And you think about, for example, random group of voters to predict the behavior of an entire state. So doing a sample of a state we'll say, for example, analyze a subgroup such as women under 30 for a particular issue. Will give you a fairly accurate result of that particular issue from that particular state for all women under 30. So a small sample, simple, but it definitely provides you with a fairly accurate interpretation of the results. So current data methods can infer results based on a small sample, which is the example I just used. Another example, exit polls on election night. So in most countries, when an election is actually produced, there are exit polls with some kind of survey, sampling of survey questions. So in essence, you don't actually sample everyone that voted. You take just a sampled group based on the criteria I mentioned before about sample data. And this will give you fairly accurate results of the larger group. So the result is create simple tests over huge data sets. So manage large data sets, but create simple tests to manage those data sets. And again, back to the sample data. Collect all data that is feasible based on the criteria of your sample data, so the requirements and the criteria, and decide after how to use it. Example here. Now, if you're not familiar with this is actually in Las Vegas, and it's Caesar's Palace. And what this is created from is it's actually a street view used through Google Street View. Now, what Google does is they actually used to use a very complicated formula that actually had about 150,000 photos to create this one particular Street View, and with a complex algorithm. But what they did is they moved away from that actual algorithm, and they went only with a subset. And what they did is some of the information that was to be digitized, they filled it in with an assumption algorithm. So they simplified the actual algorithm and the method of actually obtaining the sample data to create the Street View. Amazon, another great example. Now, most of you have probably used Amazon online to, if not purchase something, at least to basically review or look at various products. And what Amazon's done is that if you look at anything on Amazon, they've built an aggregator. It's a recommender system. So you'll know that if, say, for example, you're looking to buy a particular book by a particular author, and you'll notice at the bottom of the screen, Amazon says, we also recommend these following titles based on your suggestion. So again, they've simplified it as well. They're using a data sampling technique, taking large amounts of data from basically thousands and thousands of people accessing their website, and they're using that aggregator to create on a small data sample the recommended suggestions. Testing opportunities, number 4. There are a lot of opportunities. So emerging technologies. There will be lots. There already are a few that are out there for handling big data sets. But there will continue to be an emerging trend of technologies on the horizon for better analytics that are innovative. Test automation. As we move forward and having to handle larger data sets and the data construct, the issues around the 3 V's, test automation will be increasingly be present. So being able to create automated scripts for handling certain sections of your testing process. Test management will become even more critical. Think about the fact that now that you have all these constraints and characteristics that you have to deal with big data, you'll have to actually manage the entire process and all the tools that are used within that process. So it'll be critical to actually have management platform to manage all those variables. Enormous source of information. It'll be critical to build a knowledge base for critical decisions. So reusing that knowledge base because of the velocity, the volume, and variety of data. Enterprises will have to seek validation. Does that mean? A few things. Quality will become even more critical. Examples, application design. So apps are being created almost in real time, and the expectations for apps, whether it's from your iPhone or your Android or whatever, is that the consumer expects it to work and to be of high quality. Data security, increasingly more important. Source verification, being able to verify the source of that data. And compliance with industry standards isn't going to go away, and in fact, if anything, it will increase. So all of those are going to increase the importance of quality in managing and testing our data. Magnitude increases, meaning that I'm going to have to deal with the fact that all data that gets created, the emphasis will be more on performance, speed, security, and the load, which all has to be qualified. This will change how we test. So example, reorganize how we group and structure data sets and how we think about structuring those data sets. Number 5, lessons learned. Now, in no way is this actually to suggest that this is the right all to be all. These are lessons learned through our organization and my experience on managing large data sets and also the trends that are in the marketplace. Key is how we think and what we use to test big data, which will require flexible, innovative tools and processes. What will excel in this is the fact that the organizations that manage and test big data, the ones that will compete and excel, will empower their developers, their testers, their entire enterprise with the freedom to experiment and innovate with new methodologies, thinking, and tools. Definite competitive advantage. Lesson number 2. Testing will need to acquire the ability to think in more simplistic terms and also have to be able to drive the goals of the business, make sure it aligns the goals of the business with the testing environment. Critical to how you manage the data sources and the data types and how it's tested and how it's interpreted in your business. Lesson number 3. Enterprises will definitely adopt, and they're doing now, will definitely adopt the next generation of integration platforms and techniques, which will only drive the demand for quality assurance as we move forward in basically a paradigm shift in how we test and interpret big data sets. And I gave you a few examples of those already, so it's already happening. Testing data evolves. It'll be key to understand the events to make those decisions how we interpret that data. And we're more likely to discover the results may be probabilistic rather than certain. So meaning that when we take the data sampling, we're going to have a paradigm shift in how we think and determine those data sets. Last one, big data is emerging discipline, and it's leaving a profound impact on the global economy. And the ability to manage those and how we actually explore testing the big data sets is a topic that's going to continue to be a hot spot. And what we'll see is, and we're seeing it now, is trends in terms of innovation of both software and methodology that will have to match the emerging requirements of testing big data. So number 1, collect and use a lot of data rather than a small quantity. So I'm summing up what we just talked about. But remember that the sampling size is what's key. Accept messiness in your data. So we talked about structured data, which we're all more comfortable with, we're used to. The reality is that when we're talking about the Internet of Things and the content that comes from the Internet of Things, is that it's going to be a mix of structured, unstructured, and semi-structured. We have to accept that and be able to manage how we actually interpret it and use it. And then last is a shift and not ask why, but what we want out of that data. It's not why was the data created, but how we want to actually use it. What happened. So here's some resources. The resources I would suggest. This presentation will be available on our website as an on-demand webinar afterwards. But there's some key areas here. One is that I encourage everyone to look at the Big Data, a Revolution That Will Transform How We Live, Work, and Think. Its authors is Vic Meyer-Schroberger and Kenneth Kuki. Also, if you wanted to learn more about the 3 V's, the data construct, move to go to the Gartner Technology Topics, Big Data. There's a lot of information that's there about the data constructs, or Google data constructs as well, the 3 V's. We also, I'm happy to say that we're actually publishing a big data testing white paper, feel free to contact myself if you want some more information on it. And then if you're looking at interested in our tools, our software products, you can go to polarian.com, downloads, and I encourage you to try out a test drive of our quality assurance, our test management product. Thanks very much. Have a good morning, afternoon, or evening. Thank you.